Lesson 6, cubic functions. So this is your information for cubic functions if you need to remember any of the information. If you're unfamiliar with the shape, this is the shape that is made when it has a positive leading coefficient. So it starts down and ends up. So this one also has a positive leading coefficient, but because this one starts up and ends down, this one has a negative leading coefficient. So it's good to become familiar with how those shapes look. Okay, now working with the shapes of cubic functions, they can either have one x-intercept, two x-intercepts, or three x-intercepts. If it had one x-intercept, what it would mean is that your bump would be below the line or above it, and it would only go through the x-axis once. So it could look like that, or it could look like that. So both of these have one x-intercept, and they're both positive and negative. So for this one, two x-intercepts has to go through the line once, comes down, touches it, but then comes right back up again. So that is how you would have two x-intercepts. So it could go the same starting the other way. I just did the same thing. Oops. So it goes down, touches it, and comes down. Three x-intercepts goes through both times. So it crosses once, twice, and then three times on the way up. So it would look like that as well. So 1, 2, 3 different x-intercepts. There's two possibilities for turning points. The first is if you have one turning point. So one turning point would look, or two turning points, sorry, looks like this. So the reason why there's two is it goes up to here, it turns, comes down, so it turns right here, and then it hits right here again and turns back up. So it turned up. And there's one turning point here and here. So that is why that has two turning points. One turning point, or sorry, there's no option for one turning point, but there is an option for no turning points. And it would look like this. So it changes the shape, but it still keeps going down. You could do the same thing going up. So it doesn't turn, it just keeps going up. Okay, for the following graphs, we want to find all the information. So for our degree, because it's a cubic, it's 3. So the shape is cubic. The number of x-intercepts for this one is 2. It crosses here and here. And our x-intercepts are at 0, and they're at 2. So at each of those spots. The y-intercept is where it crosses the y-axis, so it's at y equals 0. The end behavior, it starts in quadrant 3, and it ends in quadrant 1. There are two turning points. Goes up, then down, then up, so it turns twice. For cubics, the domain is always x such that x ER, it's an element of the real numbers, as well as the range. It's like a line. So there's all your information for that cubic. For this one, our degree again is 3 because the shape is cubic. There are 3 x-intercepts. They are at x equals, looks like negative 2.5, x equals, looks like it's about 0, and then again at x equals maybe 0.25. The y-intercept crosses at 0. So it crosses the y-axis right here. The end behavior, it starts in quadrant 2 and it goes to quadrant 4. There are 2 turning points, and then the domain is this again, XER, YER. Okay, when you're matching a graph to a function, there's 2 important things you want to look at when you're matching. So the first is the leading coefficient. So for this one, because it ends in here and goes upwards, we have a positive leading coefficient. For this one, because it starts up and then ends down, we have a negative leading coefficient. And this one is like the first one, so it has a positive leading coefficient. The next important piece of data is the y-intercept, and that's because it's our constant term. So for this one, the y-intercept is equal to 0. For this one, it's equal to -2. And for this one, it's equal to -2 as well. So now what we're going to do is we're going to match. So because this one is negative, the only one that is a negative leading coefficient is a, because there's a negative in front of the x cubed. So this graph is A. For these ones, they both have a positive. These are both positive, so now we have to be determining it by the y-intercept. So because this one ends in a -2, and this one has nothing, so that's the same as 0, B matches our first graph, and C matches our third graph. So that is how you would match those. So always check the leading coefficient and the y-intercept.